A modern skyscraper is a physical manifestation of extreme coordination. 50,000 tons of steel and glass slotted into place with millimeter precision. Yet, when tasked with complex deliverables, untrained managers rarely operate with this level of precision. Without a formal system, human beings default to sheer effort, attempting to push a project forward by juggling tasks and reacting to immediate fires. Relying on intuition or sheer effort breaks down entirely at scale. You cannot work hard enough to overcome a structurally flawed plan. This diagram illustrates the foundational axiom of project management physics, the iron triangle. Every project is bound by the specific coordinates of scope, time, and cost, which together enclose the final quality of the deliverable. These constraints are rigid. If you pull one corner, for example by slashing the allocated cost, the entire geometry warps. The other variables must adjust, or the enclosed quality drops proportionally. The inverse is mathematically identical. If a client expands the scope of the deliverable mid-project, time and cost must physically expand with it. Professional project management does not rely on motivating a team to work harder to cheat these constraints. It is the scientific discipline of controlling this mathematical geometry. To maintain control over these variables, the industry relies on the Project Management Professional Standard, or PMP. This diagram shows the complete PMP lifecycle. It reveals how professional management functions as a highly interconnected system of distinct, dependent phases. A project flows sequentially through initiation, planning, execution, monitoring, and finally, closure. The exact coordinates for the iron triangle are established here, in the initiation and planning phases. This creates the objective baseline for the entire operation. Once the baseline is locked, the execution and monitoring phases run concurrently. Their function is strictly to measure physical reality against the established math. Adhering to this life cycle provides the structural framework necessary to attempt to control project variables as the scale of work increases. Elite planning requires translating massive, abstract objectives into highly specific data points. The core mechanism for achieving this is the Work Breakdown Structure, or WBS. The WBS decomposes a vague, overarching scope into a strict hierarchy of executable subcomponents. At the very bottom of this hierarchy are work packages. Because these units are singular and defined, managers can accurately attach precise dollar amounts and hourly estimates to them. Without a fully quantified WBS, any attempt to assign resources or track team progress is entirely guesswork. The WBS locks down the scope corner of the iron triangle, transforming a conceptual goal into a calculable baseline where accountability is absolute. Once the individual components are quantified, they must be sequenced based on strict logistical dependencies. Step B cannot begin until Step A is physically complete. Mapping these dependencies reveals the critical path. This is the longest unbroken chain of dependent tasks in the network, and it dictates the absolute minimum time required to finish the project. To forecast this timeline accurately, managers use the project evaluation and review technique, known as PERT. PERT discards optimistic guessing. Instead, it requires 3 separate estimates for every task: an optimistic duration, a pessimistic duration, and the most likely duration. By running these 3 variables through a weighted formula, PERT calculates the exact statistical probability of meeting the target deadline. Together, the WBS and PERT build a mathematically defensible baseline, stripping human emotion, bias, and false optimism entirely out of the planning phase. Once execution begins, the central tension for any manager is objective visibility. How do you prove a multi-million-dollar project is actually on track before a failure occurs? This chart displays Earned Value Management, or EVM, the definitive instrument panel to track live projects. The first metric is Planned Value, or PV, our baseline budget trajectory. The second is Actual Cost, or AC, tracking the raw capital burn to date. Inexperienced managers typically stop here. If their actual cost is sitting below their planned value budget, they report to stakeholders that the project is succeeding. They ignore the third crucial metric, Earned Value, or EV. Earned Value quantifies the physical work actually completed by the team, translated back into dollars. EVM completely destroys the false illusion of progress. Your spending might be lower than your budget, but if your physical earned value is even lower, the project is failing in the shadows. Comparing metrics calculates exact variances. Here is cost variance, or CV. If earned value sits below actual cost, you are bleeding capital. The same applies to schedule variance, or SV. If earned value is lower than planned value, you are physically behind schedule. EVM relies on cold mathematics. It takes vague, qualitative status updates and replaces them with absolute proof of your performance against the iron triangle. Negative variances on an EVM chart are not just reporting metrics. They are operational tripwires that immediately activate a project's defensive systems. This is where formal risk management is deployed, utilizing protocols like failure mode and effects analysis, or FMEA. FMEA requires project managers to pre-calculate the exact severity and probability of specific failures long before ground is ever broken. When an EVM tripwire is crossed during execution, there is no scrambling or guesswork. The exact contingency plan engineered during the FMEA phase is immediately deployed to correct the variance. Professional management accepts that deviations will occur. It succeeds by pre-engineering calculated responses to protect the iron triangle. This brings us to the final phase of the project lifecycle, closure and auditing. During closure, the team harvests operational data from the completed cycle. The precise EVM variances recorded over the last year become the historical baseline. Those real-world numbers are fed directly back into the organization, refining the WBS and PERT estimates for the next project. PMP methodologies establish a continuous, closed-loop system of organizational learning. This creates a data-driven environment where future execution is informed by the precise measurements of the past.